Welcome to video 5.3e, another proof with parallel lines. So I'm going to do example 4. I've modified it slightly to make it easier, otherwise it's a detour proof and it's several steps and too confusing. So here's the problem. I'll mark it up as we go. Given AB is parallel to DC, so again, I'd like to extend those. And AB is congruent to DC. So I'll just do this in a different color. Prove that angle ACB, that's this angle over here, is congruent to angle CAD, that's this angle over there. Okay. Well, what I'm going to do is try to get triangles congruent. You might say, hey, I've got a parallel line here, a parallel line here, with a transversal. However, that would only get me this angle here and this angle here. Remember, it's got to be an angle with a side on the transversal and the parallel line. So here's the transversal and here's the parallel line. Here's the transversal and here's the parallel line. So those are the angles I would get. So that's a common mistake. Okay. So maybe I could get triangles. I don't know if I'll be able to get these small triangles, but what I can do is get these larger triangles. So let me just outline them as such. I can get that triangle in red. Let's see with that triangle in blue. I've already decided, let's see here. I've already decided I can get this angle here with this angle here by the alternate interior. They gave me that with that, and I would have reflexive. So it looks like I'm going to be able to get side, angle, side. Okay, so my analysis is done. I'll get the triangles by SAS, and then I'll use parts. So again, I'll write down SAS. And please correct your notes to make sure that you reflect that we're only trying to get those angles congruent. Okay. So I'll go in SAS order. So I'll start with this step right here. I'll go in black. So AB is congruent to DC. That was given. Then I'm going to go with the angles. So I'll use the parallel. So I'll go AB is parallel to DC, that was given. And from that, again, as I mentioned before, that angle will be congruent to that angle. On the parallel, on the transversal. On the parallel, on the transversal. I'll have to use 3 letters here. So angle BAC would be congruent to angle DCA. If parallel, then alt interior angles are congruent. Again, they're on the interior and alternating sides of the transversal. Okay, so that's my angle. Then my side was by reflexive. AC is congruent to AC by reflexive. Now I'll get the triangles by SAS. Triangle BAC. I try to do those angles in the correct corresponding order, but let's just make sure. From B to A to C, from D to C to A, by SAS. And then I want to get angles ACB. So C is the vertex, the last one. A is the vertex, the last one, so that does make sense. So vertex, vertex C and vertex A, that does line up. So now I could get angle ACB is congruent to angle CAD by CPCTC. So there you have it. How to do another proof involving parallel lines.